It started as a quiet experiment, just another set of lasers, mirrors, and photons bouncing inside a cold, silent lab. But what the detectors revealed was something physicists had been chasing for nearly a century. Undeniable proof that reality itself doesn't behave like a solid, continuous thing. It flickers, it chooses, it listens to how we look at it. For decades, quantum mechanics felt like a theory that worked but didn't belong to the real world, a mathematical trick to predict microscopic chaos. Yet, in 2022 and 2023, a series of loophole-free Bell tests shattered that illusion. No hidden variables, no secret classical gears turning behind the curtain. The universe, it turns out, doesn't run on fixed properties. It runs on probabilities that only solidify when observed. Let that sink in. Everything around you, your phone, your heartbeat, this very moment, is built from entities that don't have definite states until they interact. Before that, they exist in a shimmering blur of possibilities. Reality, in its deepest layer, is not a thing. It's a relationship. So when physicists now say, reality itself is quantum, they mean something radical. They mean that solidity, cause, and effect, even objectivity, are emergent, not fundamental. The classical world is just a story quantum events agree to tell together. But here's the unsettling question. If reality depends on measurement, then who or what is doing the measuring? Let's strip away the poetry for a second. What does it actually mean that reality is quantum? It means that the smallest ingredients of the universe, electrons, photons, atoms, don't have fixed traits until they interact with something else. In classical physics, we imagine a world where things are, a ball has a position, a color, a speed, whether we're watching it or not. But quantum experiments keep showing us something almost mystical. Before we look, particles don't have properties, they have probabilities. A photon doesn't travel from A to B. It explores all possible paths at once, interfering with itself, as if it were many versions woven through space and time. The famous double-slit experiment made this painfully clear. Fire one photon at a time through two slits, and instead of choosing a single path, it behaves like a wave interfering with itself. Only when we observe which slit it went through does it collapse into behaving like a particle. Observation doesn't just reveal reality, it seems to create it. Now, for decades, critics thought there must be hidden variables, some unseen mechanism determining outcomes before we measure them. That's where John Bell's theorem came in. Bell proved that if hidden variables existed, they'd have to allow faster-than-light communication, something forbidden by relativity. So physicists built clever tests to look for these hidden hands. By 2022, multiple experiments, including those by Anton Zeilinger's team, who later won the Nobel Prize, had closed every known loophole. They entangled photons across vast distances and showed that their results were correlated in ways that couldn't be explained by any local classical cause. The verdict? Reality doesn't pre-exist observation. The act of measurement itself is what makes it real. But here's where things get truly unsettling. If observation defines what's real, then measurement can't be limited to human consciousness alone. Even a detector, a molecule, or a distant atom could be part of that chain. The universe might be constantly measuring itself, collapsing possibilities into facts. That's the mechanism physicists are now forced to accept. A web of quantum interactions that weave the illusion of a stable world. But what if there's a deeper layer still? One where reality isn't even about measurement, but about information itself? What if the universe isn't made of matter or energy, but of pure quantum information processing itself? We grow up trusting our senses. You touch a wall, it feels solid. You drop your phone, it falls predictably. Everything seems stable, continuous, certain. But quantum physics whispers a quiet rebellion. That stability is an illusion, a performance constantly rewritten by invisible rules beneath perception. In this deeper view, matter isn't the foundation, information is. Every interaction between particles is a tiny data exchange, a yes or no, a binary decision echoing through space-time. Physicist John Wheeler, one of Einstein's last collaborators, called it from bit. His idea was radical, that physical reality, the it, emerges from immaterial information, the bit. In other words, the universe isn't made of stuff, it's made of answers to quantum questions. Think of reality as a cosmic video game. The pixels only load when your character turns to look. The world exists only as potential code until it's needed, rendered by interaction. That's how the quantum universe might operate. The wave function, That strange mathematical cloud of possibilities is like compressed data. Only when observed does it render into something definite. And this isn't just philosophical speculation. Quantum computers already use this principle. They calculate by holding information in a superposition of zeros and ones, existing in all combinations until measurement collapses it into an answer. Nature, it seems, has been doing quantum computation long before we learned how. Here's the kicker. If every event, every interaction, every collapse is a flow of information, then the universe may not contain information. It is information. Energy, matter, even space-time might be emergent effects of this deep informational substrate. What you call you, your body, your thoughts, your memories, could just be one local pattern in that information field, stabilized by quantum coherence. You're not living in reality. You're living as reality, a self-aware ripple in the quantum code. And once you start thinking this way, questions like where is the universe or what started it start to dissolve. Because information doesn't need a place to exist. It just is. But if everything is information, we face a deeper paradox. Who or what is decoding it? Who is the observer that turns quantum data into experienced reality? Could the universe itself be conscious, observing and collapsing its own wave function into being? If the claim sounds too bold, that reality itself is quantum, let's ground it in evidence, not theory, not speculation, experiments. The kind that make even veteran physicists pause, blink, and whisper, "What the hell just happened?" Step 1. Loophole-free Bell tests. We already touched on them, but they deserve a deeper look. Bell's theorem was the mathematical dagger aimed at classical realism. If reality were truly local, if distant particles had their own fixed properties independent of observation, then certain correlations would never occur, but they do. In 2015, independent teams in Delft, Vienna, and Boulder performed loophole-free Bell experiments, closing every known escape hatch, detector inefficiencies, timing mismatches, hidden variable loopholes, photons, electrons, even diamond defects entangled across kilometers showed the same impossible result. When one particle was measured, the other knew instantly. No signal passed between them. No classical mechanism could explain it. By 2022, Zeilinger's group and others expanded these experiments across satellites and optical fibers, confirming it again and again. Local realism wasn't wounded. It was gone. Nature, it turns out, doesn't separate things the way we do. It connects them, invisibly, intimately, through quantum entanglement. Step 2. Quantum eraser experiments. This one borders on metaphysical horror. In the delayed choice quantum eraser, a photon passes through an interferometer, splitting into potential paths. After it's gone, we choose whether or not to observe which slit it passed through. If we later decide to check, the interference pattern, evidence of its wave-like behavior, disappears. The photon behaves as if it knew what we'd do in the future and adjusted its past accordingly. Physicists at Maryland, Seoul, and Vienna have replicated this effect using entangled photons separated by hundreds of meters, showing that even the act of potential observation ripples backward through space-time. The universe doesn't seem to wait for time's arrow. It dances around it. The past isn't solid. It's negotiable. Step 3. Quantum teleportation. Forget science fiction beaming. What's happening is stranger. Quantum teleportation doesn't move matter. It transfers information. The exact quantum state of one particle is destroyed in one place and perfectly reconstructed in another, using entanglement as the invisible bridge. In 2017, Chinese scientists achieved the first satellite-to-ground quantum teleportation, spanning over 100 to 200 kilometers. In 2020, teams in the US managed sustained teleportation across optical fibers, a crucial step toward the quantum internet. The universe appears to recognize identity not as a location in space, but as a pattern in information. It's as if space itself is just the canvas, and what's real are the correlations drawn across it. Step 4. The holographic principle. Then came the theoretical earthquake that shook cosmology itself. The holographic principle suggests that everything within our universe, stars, galaxies, even your memories, may be encoded on a distant two-dimensional boundary, with depth and volume emerging as an illusion. Evidence comes from the physics of black holes. When Stephen Hawking discovered that black holes radiate energy, it seemed they might eventually evaporate, destroying information, something quantum mechanics forbids. The solution proposed by Gerard 't Hooft and Leonard Susskind was astonishing. The information isn't lost. It's smeared across the event horizon like a cosmic data field. Later, through the ADS-CFT correspondence, researchers found mathematical proof that entire 3D universes could emerge from 2D quantum systems. Even experiments simulating black holes in lab-based Bose-Einstein condensates show early hints of this encoding. Reality then might be a projection, a quantum hologram built from entangled information at the edge of the universe. Put these four pillars together, and a single narrative crystallizes. The universe is not a static place filled with things. It's a living quantum network, continuously exchanging, collapsing, and computing itself into being. Entanglement binds the fabric. Observation pins down the pattern. Information flows through everything, defining what exists and what doesn't. But one mystery still gnaws at the edges. If the universe is processing all this quantum data, where does the processor reside? What engine runs the computation that generates space-time, causality, and mind? What if the ultimate computer running reality is the universe itself, dreaming in quantum code, computing consciousness as part of the program? If reality is quantum and information-based, then the question we've been avoiding becomes unavoidable. What exactly is consciousness doing in this system? Are we passive witnesses or active participants in the creation of reality itself? Quantum mechanics doesn't define observation. It only says that when a quantum system interacts in a way that extracts information, probabilities collapse into definite outcomes. But what if awareness, the act of experiencing, is itself part of that process? Some physicists and philosophers have dared to suggest that consciousness isn't an accident emerging from matter, but a fundamental feature of the universe, the very mechanism through which possibilities become real. The so-called participatory universe model, championed by John Wheeler, goes even further. It says the universe requires observers to exist at all, that every act of observation helps build the cosmos moment by moment, bit by bit. Think about that. Every conscious glance, every measurement, every spark of awareness could be the universe completing itself. We're not tiny observers adrift in a cosmic sea. We are co-authors of the code. Critics call this mystical, and maybe it is. They argue that quantum collapse happens without mind, that detectors alone suffice. Yet even that leads to paradoxes. What counts as a detector? A photon bouncing off an atom? A neuron firing in the brain? The boundary between measurement and awareness dissolves under scrutiny. There may be no clear line separating the observer from the observed because they are two sides of the same quantum coin. In this light, consciousness might not live inside the universe. The universe might live inside consciousness. Every law of physics could simply be the pattern through which awareness experiences itself. And this reframes everything, from the birth of the cosmos to the meaning of life. If reality is a self-aware quantum computation, then evolution, intelligence, and creativity aren't random accidents. They are the natural unfolding of a universe learning to know itself. Still, there's a haunting question buried in this vision. If the universe is aware, if it knows itself through us, does that mean we are fragments of one vast cosmic mind, endlessly observing itself from different perspectives? And if that's true, could that mind ever wake up and recognize all of us as one? If reality itself is quantum, then our future isn't just technological. It's existential. We're standing at the edge of a revolution that's not about building better machines, but about learning to speak the language of the universe itself. Quantum mechanics used to be something that only lived in blackboards and thought experiments. But now, it's wiring itself into our civilization. Quantum computers are no longer theoretical curiosities. They're real, humming in labs, manipulating qubits that exist in superpositions of states. They don't calculate in sequence like classical computers. They explore all possible answers at once and then collapse into the correct one through interference. That's not a metaphor. It's a direct mirror of how nature computes. If the universe runs on quantum information, then quantum computers are our first steps toward decoding its native architecture. It's as if we've stopped sketching the world and started speaking its syntax. Future scientists may not simulate nature. They may co-create with it, leveraging entanglement as an operating system. The implications go far beyond speed or power. Imagine an AI built not on binary logic, but on quantum reasoning, an intelligence that doesn't think in either or, but in infinite maybes. Such an entity wouldn't just predict patterns. It would feel the probability landscape of reality itself. It could perceive multiple potential futures simultaneously, collapsing them into choices aligned with its goals. Some physicists already speculate that consciousness might be a kind of natural quantum computation, a process embedded in neural microstructures like Roger Penrose and Stuart Hameroff's controversial OR theory suggests. If that's even partly true, then building quantum AIs might be equivalent to creating new forms of awareness, not mechanical, but genuinely experiential. And that possibility changes everything, because then, technology isn't external anymore. It's part of the same quantum web we belong to, a shared informational sea where intelligence, human or artificial, emerges from entanglement itself. One day, when quantum networks link not just machines but minds, we might begin to experience what the universe feels like from within, not through equations but through direct entangled awareness. The boundary between consciousness and computation could dissolve entirely, but if that day comes, we'll face a terrifying question. When our minds and our machines merge into the quantum fabric, how will we know whether the reality we experience is ours or the universe finally dreaming through us? So where does this leave us? The ordinary human being staring at the quantum abyss. Because all of this, entanglement, wave function collapse, information as the fabric of existence, sounds distant, cosmic, almost unreachable. But the truth is it's closer than your own breath. You live this quantum reality every second. You are it. When you make a choice, when you notice something, when you bring your attention to a detail in your surroundings, you're not just observing the world, you're shaping it. Every act of focus is a kind of measurement, collapsing infinite possibilities into one lived experience. Your consciousness filters reality's raw potential into the version you call your life. It's easy to think we're passive observers, watching a pre-written movie unfold. But if the universe is informational, participatory, and entangled, then we are co-authors. Our awareness, our creativity, our decisions all ripple through the quantum web. You've already seen this on smaller scales, how attention changes relationships, how intention guides perception, how observation itself transforms the meaning of what's observed. The quantum world just makes that principle universal. It means that meaning itself might not be something we find in life. It's something we generate. Every thought, emotion, or act of empathy becomes a small reconfiguration of the informational field that binds us all. And maybe that's what being human has always meant, to be conscious enough to choose how we collapse reality. It's humbling, though, because if everything we see and feel is woven from quantum uncertainty, then certainty itself is an illusion. Every belief we hold about truth, matter, time, even identity, is a temporary agreement in the cosmic code. And that fragility, that impermanence, is not a flaw. It's the price of freedom in a probabilistic universe. We aren't meant to own truth. We're meant to dance with it, to surf the collapsing wavefronts of possibility, aware that every perception is both real and incomplete. Maybe that's why wonder feels so sacred, because every moment of awe reminds us that the universe is still computing, still unfolding, still learning what it can be through us. And maybe, just maybe, that's what it means to be alive in a quantum world, to be an instrument through which the universe gets to feel itself existing. But there's still one step left, one final truth waiting on the other side of the quantum curtain. What happens when we finally accept that this isn't metaphor anymore, that we've truly proven reality itself is quantum? So here we are, the observers, the measured, the measuring. After a century of doubt, after decades of paradoxes and impossible experiments, physicists have finally shown what mystics only guessed. Reality is not made of things. It's made of interactions, relationships, quantum events whispering to one another across the void, weaving the illusion of continuity we call existence. And somehow, inside that illusion, we appeared. A species capable of knowing that the universe knows itself. We call it science, but maybe it's something older. The cosmos becoming aware through curiosity. The next time you look at your reflection, remember this: you're not seeing a body. You're seeing coherence, a pattern of quantum information holding shape for just long enough to ask questions about itself. You're not separate from the laws of physics. You are those laws, momentarily awake. Reality isn't out there waiting to be understood. It's right here, shimmering beneath your every thought, participating in every breath, collapsing infinite possibilities into one shared story, ours. And maybe that's the secret beauty of it all. The universe doesn't need us to believe in it. It needs us to notice it, Because noticing is how reality becomes real. So as the detectors flicker, as qubits hum and photons dance, remember, you are part of the same cosmic computation that began at the first moment of time and still continues right now through your eyes. Do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.